introduction. Water supply system means the whole system containing water, public main drains, chamber, treatment plant, pumping station or some mix of operation or balancing reservoir. Water is distributed to customer from natural source and preliminary treatment is carried out. It is responsible for providing the user with water from wells, lakes or storage plant. The central source of water can be put both on the surface and underground. The cheapest, distinguished by rapid installation, is the first installation choice for the water supply system, says Dr. Richard Branson. He says water supply system can be used to provide different economic artifact and settlement with water in the UK. The minimum flow that would be satisfactory for every section of the premise would vary substantially on the customer. Distributed network carry water drawn from the source of water to the point of which it is delivered to consumer. It is cost of the hour. Water intake is most essential for personal hygiene and washing. The consumption of water is lowest at night.
Assalamualaikum, I'm Amira. I'm presenting the literature review which lead to the water distribution system and water treatment plant. Essentially, the method what we use in Malaysia are water treatment plant to get the consistency of water to make it suitable for a particular end use. Because of the effectiveness of water treatment strategy, we can use in industrial supply and drinking water for consumer. It's safely used because of the advanced technology filtration. Second point of view, can address e-PANET is widely used in water distribution industry because of the program developed by technology to analyze the movement and fate of the component within system. Last but not least, water demand for the consumer can be characterized as the amount of water. Thank you.
Okay, next I will explain about the methodology of this project. So, raw water sources from the natural sources are treated at the treatment plant water and stored temporarily in a water tank before distributed to the selected area. For completed this task, Atira's house has been selected as her residence area are the closest to the water treatment plant and easiest to understand the pipeline from the water treatment plant to her residence area rather than others group members. Taman Teja, that located in Ara Perlis, received treated water from storage tank with a total distance of 926 meter and the total distance of the pipeline from Ara water treatment plant to the water storage tank is 450 meters. From the observation, along the way from the Ara water treatment plant, we found that there are 2 valves and 1 centrifugal pump are used to make sure the treatment water flow in a good condition and to ensure selected area receive adequate water supply. In addition, the treated water was also distributed to the 2 demand that located in the area near the residence, which is 10 unit shop lot and mosque. After doing an interview session with the staff at Ara water treatment plant, we found that the type of pipe is used for water supply system in that region is using a cement line mild steel pipe type.
Next is about result and discussion. In this project, we are covering the water demand needed in Taman Teja, located in Arau Place. The area consists of 84 units of single-story terrace house, 56 double-story terrace house, 10 single-story shop houses and a surau. We are estimating the people who live here in this covered area are about 1,500 persons. The nearest water treatment plant is in this area is Arau water treatment plant, and the water was stored in Taman Teja water storage tank before it was distributed to the people in this area. The total length of pipe covered in this area is about 7,923 meters with variation of diameter of pipes. The diameter of pipe from water treatment plant to water storage tank is 400 mm. The diameter of pipe from water storage tank to junction at Taman Teja is 375 mm, while the diameter of this distribution pipe in Taman Teja is 300 mm and 200 mm. There are two valves in this area, which is at link number 7 and 11. Okay, for manual calculation, with the population of 1,500% is in this area, the total water demand needed is about 254,000 liter per day, which is equal to 3 liter per second. The maximum value of daily water demand is 4.7 liter per second, while the peak hour demand needed in this area is 7.4 liter per second. Although the amount of water needed for emergencies such as for firefighting for a year is a small, but the rate of usage is large since the fire demand for this area is about 3.5 liter per second. The total value of capacity needed to supply for this area is 8.1 liter per second. Okay, this is the amount that we use for base demand in EPANET software. Okay, for EPANET software, the value of total heat located in water reservoir is estimated as 100 meter, and it needed to get through for 32 links, which is pipe, 2 valves, and 30 nodes that include junction, tank, and water reservoir. Okay, for node, the highest value of base demand is 12.5 liter per second, while the lowest value is 8.1 liter per second. The greatest value of height is 83.3 meter at node number 3 because the node is located near to the water treatment, and the lowest value of height is 31.85 meter at node number 33 since the nodes are located at the end of the distribution system. Okay, the highest pressure is 32.3 at node number 33, which is the same reason with the value of height, while the lowest pressure is 0.24 meter located at number 18 because it is positioned at the edge of the junction. For link, the range of flow is between 809 liter per second at link number 33 and 4.9 liter per second. Okay, the lowest flow happened in link number 17 because the link is located at the end of distribution system and the water was distributed at the other link before passing through the pipe. The higher velocity is 6.5 meter per second, which is located at link 37, and the lowest velocity is 0.27 meter per second. The lower velocity mostly located at the end of system since the water needs to get through a long journey, which is the factor of length, junction, and roughness. Last but not least, the highest head loss is 123.8 meter per kilometer that are located in link number 39. This is due to the link that have most of the highest values such as flow. Okay, and their lowest head loss is 0.44 meter per kilometer at link number 17 since it also have the low value of flow. Okay, that's all for result and discussion.
And now, as a conclusion, Taman Teja has been a magnet for continued and often uncontrolled urban growth. A history of federally subsidized water service and poor financing while encouraging economic development has limited the capacity of the government to expand the network, treat water and wastewater, and fund repairs. Recently, the local authorities have moved toward more efficient management of the region's water supply resources. Then, more attention should be given to managing water demand through pricing mechanism, education and conservation and reuse programs. There are several general recommendations of a diverse nature concerning improved understanding of the regional hydrology, reuse of reclaimed wastewater, protection of the quality of existing resources, greater efficiency of use, and institutional change, all designed to improve the existing system. Alright, firstly, in addressing the issues or challenges occur in water supply system, since both water supply and wastewater sector do not as yet have a national policy, it is timely that a national water services policy be developed to complement the NWRP 2012 by the Ministry of Natural Resources and Environment, as well as the National Green Technology Policy, which was launched in 2009. They could provide the necessary clarification on the policy for different states. The national policy objective pertaining to sewerage services must be well defined to ensure that sewerage industry will progress on the right track. Government facilitates deficit water entities by providing grants until the new tariff are able to recover the operational expenses. Alright, next, we need to establishment of a fair and efficient tariff mechanism. Water tariffs should be reviewed at regular intervals until they reach full cost recovery before 2030. Any increase in electricity tariff should automatically lead to an upward revision of water tariff. A strategy of full cost recovery should be targeted for sustainability of the water supply industry. The current water tariff setting mechanism must incorporate this objective. And lastly, we must enhance the water safety plan, or WSP. It is recommended that SPAN enforce mandated WSP formulation and implementation. The following targets could be said to be achieved by the industry. Okay. Firstly, enforcing the development of a WSP for all water and sewerage system. Next, utilizing WSP in improving operation and maintenance. Number 3, utilizing WSP in the budget for improvement works to reduce risk and enhance reliability and efficiency. And lastly, all water operators to adopt WSP, which covers from source to tap. Study further suggested that water NGOs such as the Malaysian Water Association play a role in promoting WSP even at ministry level to get support from water agencies such as JBA Malaysia and SPAN. The importance of WSP needs to be highlighted and adequate funding to be provided to water operators to develop and implement WSP. That's all from me. Thank you.